30 soldiers trapped on a mountain ledge, one critically injured pilot, and a 300-meter cliff that stood between them and survival. Davis calculated the climb time, rope strength, and his own endurance against incoming storm conditions. The math said rescue was impossible. Military Brotherhood said start climbing. The helicopter wreckage smoldered on an inaccessible ledge 300 meters above the valley floor. Weather reports showed incoming storms with 60 miles per hour winds and freezing temperatures. Professional rescue teams were 12 hours away. Hypothermia would kill those soldiers in 6 hours. Sometimes impossible is just another word for necessary. In the rugged mountain terrain of eastern Afghanistan, search and rescue operations required specialized personnel trained in high-altitude rescue techniques, technical climbing, and emergency medical procedures that could save lives in environments where conventional rescue approaches proved inadequate due to terrain challenges, weather conditions, and tactical constraints that limited access to standard emergency services. Rescue Specialist Staff Sergeant Marcus Davis served as the Senior Mountain Rescue Coordinator for Regional Command East with expertise developed through extensive civilian mountaineering experience, military rescue training, and specialized certifications in technical rope rescue that qualified him for operations where vertical terrain and extreme conditions challenged conventional rescue capabilities. Davis possessed 12 years of combined civilian and military climbing experience including advanced certifications in technical rescue, wilderness medicine, and high-altitude operations that enabled complex rescue missions in terrain where standard procedures required adaptation to environmental conditions that exceeded normal emergency response capabilities and equipment specifications. His civilian background included professional mountain guiding, technical rescue instruction, and expedition climbing that had taken him to some of the world's most challenging mountain environments where rescue operations required individual expertise and equipment that exceeded standard military training and capability for personnel recovery in extreme environments. Military rescue training had included specialized courses in combat search and rescue, helicopter operations, and tactical medicine that prepared rescue specialists for operations where enemy activity, weather conditions, and terrain challenges combined to create rescue scenarios that exceeded conventional emergency response procedures and required innovative approaches to personnel recovery. Davis's expertise extended beyond basic rescue techniques to include advanced rope systems, emergency medical procedures, and equipment improvisation that enabled rescue operations using available resources when specialized equipment wasn't available or environmental conditions prevented use of standard rescue procedures that required optimal weather and terrain conditions. The mountain environment in eastern Afghanistan presented unique challenges for rescue operations including extreme altitude, unpredictable weather patterns, unstable terrain, and enemy activity that could interfere with rescue operations while creating additional risks for rescue personnel attempting to reach isolated casualties in hostile territory. Regional Command East's area of operations included some of Afghanistan's most challenging mountain terrain where helicopter operations were limited by altitude, weather, and enemy threats that made aerial rescue extremely difficult during adverse conditions when conventional rescue approaches couldn't reach personnel stranded in inaccessible locations. Tuesday morning brought routine training operations as Davis conducted mountain warfare instruction for infantry units learning high-altitude operations and survival techniques essential for combat effectiveness in mountainous terrain where environmental challenges could prove as dangerous as enemy activity for soldiers operating at extreme altitudes. The helicopter crisis. At 1030 hours, emergency communications reported that UH-60 Black Hawk helicopter, Dust-Off 23, had crashed during a medical evacuation mission in mountainous terrain approximately 40 kilometers northeast of Forward Operating Base Highland. The aircraft had been transporting wounded soldiers to medical facilities when mechanical failure forced an emergency landing attempt in challenging terrain. Initial reports indicated that the helicopter had experienced catastrophic engine failure while operating at high altitude in deteriorating weather conditions, requiring an immediate auto-rotation landing in the only available space, a narrow mountain ledge that provided insufficient area for safe landing but represented the only alternative to controlled flight into terrain that would have killed everyone aboard. The emergency landing had been partially successful in that the aircraft remained relatively intact and most personnel aboard had survived the impact, but the helicopter's position on a narrow mountain ledge made conventional rescue operations impossible using standard procedures and equipment that required accessible landing zones for rescue aircraft operations. Davis immediately recognized the tactical and technical challenges presented by the reported crash location based on his knowledge of regional terrain and previous rescue operations in similar environments. The crash site was positioned on vertical terrain that exceeded helicopter rescue capability while weather conditions were deteriorating toward levels that would make aerial operations impossible. Emergency communications with the crash site established that 31 personnel had survived the initial impact, including the flight crew, medical personnel, and wounded soldiers being evacuated for medical treatment. However, the pilot had sustained critical injuries during the crash and required immediate medical evacuation that couldn't be provided using conventional rescue procedures. Weather reports indicated that storm systems were moving into the region with high winds, precipitation, and temperature drops that would create hypothermia conditions for personnel exposed on the mountain ledge without adequate shelter or protection from environmental conditions that could prove fatal within hours. The crash site was located on a vertical cliff face approximately 300 meters above the nearest accessible terrain where rescue vehicles or personnel could establish base operations for technical rescue attempts. Standard helicopter rescue was impossible due to terrain limitations that prevented safe aircraft operations near the crash location. Professional mountain rescue teams from civilian agencies were available but required 12 hours minimum for mobilization, equipment preparation, and travel to the remote crash site. Weather predictions indicated that conditions would deteriorate beyond rescue capability within 6 hours, creating a critical timeline that exceeded conventional rescue response times. Davis assessed the tactical situation and recognized that immediate rescue operations were required to prevent hypothermia casualties among crash survivors who were exposed to environmental conditions that would become lethal as temperature dropped and weather conditions continued deteriorating throughout the afternoon and evening hours. Davis conducted detailed analysis of rescue options using topographical maps, weather data, and technical climbing assessments that revealed the full scope of challenges facing any rescue attempt at the helicopter crash site positioned on terrain that exceeded normal rescue capability and equipment specifications. The crash site was located on a narrow ledge approximately 10 meters wide positioned on a vertical cliff face that dropped 300 meters to the valley floor. Access from below required technical climbing using advanced rope systems across terrain rated as extremely difficult even under optimal weather conditions with specialized equipment and experienced personnel. Climbing route analysis indicated that the cliff face consisted of unstable sedimentary rock with loose sections that could fail under climbing loads, limited anchor points for rope systems, and exposure to weather conditions that would make climbing extremely hazardous even for experienced technical climbers using appropriate equipment and safety procedures. Equipment assessment revealed that available rescue gear included basic military climbing equipment designed for tactical operations rather than technical rescue, with rope capacity and hardware specifications that approached but didn't exceed the technical requirements for 300-meter rescue operations under optimal conditions. Weather analysis indicated deteriorating conditions with wind speeds increasing to 40 miles per hour with gusts exceeding 60 miles per hour, temperature dropping below freezing, and precipitation that would create icing conditions on rock surfaces while reducing visibility and making rope handling extremely difficult during extended climbing operations. Time analysis revealed that technical climbing to the crash site would require approximately 4 hours for a highly experienced climber under optimal conditions, followed by rope system installation, personnel evacuation, and descent operations that could require an additional 6 to 8 hours depending on injury severity and weather conditions. Physical demands of solo technical rescue would push human endurance beyond normal operational limits as 300-meter vertical climbing while carrying rescue equipment would exhaust even experienced climbers before beginning the most technically demanding phase of establishing rope systems for personnel evacuation under time pressure. Risk assessment indicated that rescue operations would exceed safe climbing parameters due to weather conditions, equipment limitations, terrain challenges, and time pressure that combined to create rescue scenarios that professional rescue organizations would classify as extremely hazardous or impossible under current conditions. Davis understood that conventional rescue protocols would require waiting for improved weather conditions, specialized equipment, and professional rescue teams that could provide adequate safety margins and technical capability for complex rescue operations. However, crash survivors couldn't survive the time required for conventional rescue mobilization. The personal decision. Davis calculated that attempting solo technical rescue exceeded every safety protocol and risk management procedure that governed military rescue operations, but 30 soldiers would die from hypothermia exposure if rescue operations were delayed until conventional procedures could be implemented with appropriate safety margins and equipment specifications. The decision represented career-ending risk, as unauthorized rescue operations that resulted in additional casualties could lead to court-martial proceedings and criminal charges for endangering personnel through operations that exceeded approved procedures and safety standards established to prevent rescue personnel from becoming additional casualties requiring rescue. Military rescue doctrine emphasized that rescue operations shouldn't create additional casualties or risk rescue personnel unless probability of success exceeded acceptable risk levels determined through systematic risk assessment and command approval. Solo technical rescue in deteriorating weather exceeded all established risk parameters for authorized operations. Davis understood that his climbing experience exceeded that of any other available personnel, that equipment limitations made team rescue operations impossible due to rope capacity constraints, and that his technical knowledge represented the only possibility for establishing rescue capability before environmental conditions became lethal for crash survivors. Personal motivations included professional responsibility for rescue operations within his area of expertise, military obligation to attempt personnel recovery when feasible, and understanding that 30 soldiers were depending on someone with technical capability to attempt rescue operations that conventional procedures couldn't provide within available time constraints. Family considerations included recognition that his wife Sarah and 2 young children depended on his survival, and that attempting technical rescue under extreme conditions could result in his death, leaving his family without husband and father. However, 30 other families faced similar loss if rescue operations weren't attempted. Davis made the decision that defined his military career and potentially determined survival for 30 soldiers: attempt solo technical rescue using available equipment and personal expertise despite risk levels that exceeded conventional safety standards but represented the only possibility for saving lives within critical time constraints. Equipment preparation required careful selection of climbing gear, rescue equipment, and emergency supplies that could enable successful rescue operations while remaining within weight limits that one person could carry during 300-meter technical climbing under deteriorating weather conditions that challenged physical performance and equipment reliability. Davis assembled technical climbing equipment designed for military operations rather than specialized rescue, understanding that improvisation and adaptation would be required throughout the rescue operation where standard procedures needed modification for available equipment and environmental conditions that exceeded normal specifications. Primary climbing gear included military specification rope rated for rescue operations but limited to 200-meter continuous length requiring splicing techniques for 300-meter operations, climbing hardware including carabiners and protection devices suitable for sedimentary rock formations, and personal protective equipment designed for tactical rather than technical climbing operations. Rescue equipment included emergency medical supplies for treating hypothermia and trauma injuries, evacuation hardware for moving injured personnel, and communication equipment for coordinating with base operations and crash site personnel during extended rescue operations that would require tactical coordination over several hours. Emergency supplies included high-energy food for sustained physical exertion, water for extended operations in cold conditions, and emergency shelter materials that could provide protection for rescue personnel and casualties during extended evacuation operations if weather conditions required overnight operations. Technical equipment included anchor installation hardware for establishing secure rope systems in sedimentary rock, mechanical advantage systems for personnel evacuation, and emergency repair materials for equipment failure during critical operations where backup equipment wasn't available for redundancy. Weather protection included cold weather clothing rated for extreme conditions, waterproof equipment covers for electronics and rope systems, and emergency signaling devices for communication if primary systems failed during operations in deteriorating weather conditions that could prevent normal communication. Physical preparation included consuming high-energy foods for sustained climbing, hydrating for extended physical exertion in cold conditions, and stretching exercises that would prepare muscles for technical climbing while carrying equipment loads that exceeded normal climbing parameters for recreational or training operations. Mental preparation required reviewing technical procedures for complex rescue operations, visualizing critical decision points during the rescue sequence, and preparing psychological responses for situations where improvisation and split-second decisions could determine success or failure for rescue operations under extreme pressure. The ascent into danger. Davis began his technical ascent at 1,200 hours, carrying 40 pounds of rescue equipment while climbing 300 meters of vertical terrain that challenged his technical skills and physical endurance under weather conditions that continued deteriorating as predicted by meteorological forecasts that indicated worsening conditions throughout the afternoon. Initial climbing progress revealed terrain challenges that exceeded map analysis as rock quality varied significantly with sections of loose sedimentary material that wouldn't support climbing loads reliably, requiring careful route selection and constant assessment of anchor point viability for technical climbing while carrying rescue equipment. The first 100 meters of climbing required 90 minutes due to challenging route finding, careful anchor placement in questionable rock, and equipment management that slowed climbing progress while ensuring that rescue gear remained secure and functional for subsequent rescue operations at the crash site. Weather effects began impacting climbing operations as wind speeds increased to sustained 35 miles per hour with gusts approaching 50 miles per hour that created difficulty maintaining balance and equipment control during technical moves where precision was required for safety and continued upward progress toward the crash site. Temperature effects became noticeable as altitude and weather conditions combined to create wind chill approaching freezing levels that affected hand sensation and grip strength essential for technical climbing while threatening hypothermia for rescue personnel during extended exposure to deteriorating environmental conditions. At 150 meters altitude, Davis encountered technical climbing challenges that required advanced techniques including aid climbing using specialized equipment, multi-pitch rope management, and route selection that balanced climbing difficulty against time constraints for reaching crash survivors before environmental conditions became lethal. Communication with base operations became intermittent due to terrain interference with radio equipment, limiting tactical coordination and weather updates that would enable optimal decision-making during the most challenging phases of technical climbing where environmental awareness could determine rescue success or failure. Equipment performance began showing effects of environmental conditions as rope handling became more difficult due to moisture and cold temperatures, metal hardware became slippery and potentially dangerous to handle, and electronic equipment showed signs of moisture intrusion that could cause failure during critical operations. Physical demands of technical climbing while carrying rescue equipment pushed Davis's endurance toward operational limits as sustained technical climbing required continuous physical exertion while maintaining mental focus necessary for safety decisions and route finding that could determine rescue mission success or failure. At 250 meters altitude, Davis approached the most technically challenging section of the climb where vertical rock gave way to overhanging terrain that required advanced technical skills while carrying equipment loads that exceeded normal climbing parameters and challenged his ability to complete critical technical moves safely. The overhanging section required aid climbing techniques using specialized equipment while managing rescue gear that affected balance and movement capability during the most demanding technical moves where equipment failure or climbing errors could result in fatal falls that would end rescue operations and create additional casualties. Weather conditions reached critical levels as wind speeds exceeded 45 miles per hour with gusts approaching 60 miles per hour that made technical climbing extremely hazardous while precipitation began creating icing conditions on rock surfaces that reduced grip reliability and made equipment handling more difficult during precise technical movements. Route finding became increasingly difficult as weather reduced visibility while technical demands required careful assessment of rock quality and anchor placements that would support rescue operations. Davis had to balance climbing speed against safety margins while approaching the crash site within time constraints. Equipment management required constant attention as rescue gear needed protection from weather while remaining accessible for immediate use upon reaching the crash site. Tools and hardware showed effects of environmental exposure that could affect functionality during rescue operations that required reliable equipment performance. Communication attempts with crash site personnel indicated that hypothermia was affecting survivors while the injured pilot's condition continued deteriorating. Time pressure increased as Davis approached the most technically demanding section of climbing that would determine whether rescue operations could commence before environmental conditions became fatal. Physical condition assessment revealed that Davis was approaching exhaustion limits that could affect technical climbing performance during the most critical phase of operations. However, abandoning rescue attempts would guarantee fatal outcomes for crash survivors who couldn't survive environmental exposure much longer. The final 50 meters of climbing required technical moves that exceeded normal safety margins while carrying rescue equipment, but crash site sounds indicated that personnel were still alive and capable of participating in rescue operations if evacuation systems could be established before hypothermia eliminated their physical capability. Crash site assessment. Davis reached the helicopter crash site at 1,530 hours after 3.5 hours of technical climbing that had pushed his physical capabilities to operational limits while establishing access to personnel who had been stranded for over 5 hours in environmental conditions that approached lethal exposure levels for unprotected humans. The crash site revealed both positive and negative factors for rescue operations. The helicopter had remained relatively intact with minimal fire damage, providing some shelter for survivors. However, the narrow ledge limited movement and positioning options for rescue operations while creating additional hazards from unstable aircraft wreckage. Personnel assessment indicated that 30 soldiers and flight crew had survived the initial crash with varying degrees of injury and hypothermia. The pilot, Captain Rodriguez, had sustained critical injuries including suspected internal bleeding and required immediate medical evacuation that exceeded field treatment capability. Medical triage revealed multiple casualties requiring evacuation including several soldiers with fractures, hypothermia cases that required immediate warming, and medical conditions that had been exacerbated by environmental exposure during the 5-hour wait for rescue operations to commence. Environmental assessment confirmed that weather conditions were continuing to deteriorate with temperature dropping toward levels that would cause rapid hypothermia progression, wind speeds that would make rope operations extremely difficult, and precipitation that was beginning to accumulate on equipment and surfaces. Equipment assessment revealed that crash survivors had minimal cold weather protection and no technical equipment that could assist with evacuation operations. All rescue capability would depend on equipment that Davis had carried during his technical ascent and improvised systems that could be created using available materials. Time assessment indicated that evacuation operations needed to commence immediately to prevent additional hypothermia casualties while completing personnel recovery before weather conditions made rope operations impossible. Davis had approximately 4 hours of remaining daylight for complex rescue operations. Tactical planning required prioritizing evacuation sequence based on injury severity and hypothermia progression while establishing rope systems that could safely lower personnel 300 meters to accessible terrain where ground evacuation could transport casualties to medical facilities. Davis began establishing technical rope systems for personnel evacuation using equipment carried during his ascent, understanding that improvisation would be required to create evacuation capability for 30 personnel using rope systems designed for smaller-scale rescue operations under optimal conditions. Primary rope anchor systems required installation in sedimentary rock that provided questionable holding strength for dynamic loads generated during personnel evacuation. Davis used multiple anchor points with load distribution techniques that could provide adequate security despite rock quality limitations that exceeded normal anchor specifications. Rope rigging for 300-meter evacuation required splicing techniques to achieve adequate length using available rope while maintaining strength ratings necessary for safe personnel evacuation under dynamic loading conditions that would stress rope systems beyond normal operational parameters. Mechanical advantage systems were necessary for personnel evacuation as Davis couldn't physically lower 30 people manually during extended operations. He improvised pulley systems using available hardware while creating operational procedures that would enable casualties to assist with their own evacuation despite hypothermia and injury limitations. Safety systems required backup anchors and emergency procedures for equipment failure during critical evacuation phases when personnel would be suspended over 300-meter drops where rescue system failure could result in fatal falls. Davis implemented redundant systems using all available equipment for maximum safety margins. Communication systems needed establishment for coordinating evacuation operations between the crash site and base operations. Davis positioned radio equipment for optimal transmission while creating procedures for maintaining contact during evacuation operations that would require constant coordination. Personnel organization required establishing evacuation priorities based on injury severity and hypothermia progression while preparing casualties for rope evacuation that would be physically and psychologically challenging for personnel weakened by environmental exposure and trauma from the helicopter crash. Testing procedures verified that rope systems could support personnel loads while providing smooth operation during evacuation under current weather conditions. Davis conducted system verification using rescue equipment while monitoring anchor performance and rope handling characteristics that would determine evacuation success. The critical evacuations. Evacuation operations commenced with Captain Rodriguez, the critically injured pilot whose condition required immediate medical attention that could only be provided at medical facilities accessible through ground evacuation from the valley floor 300 meters below the crash site. Rodriguez's evacuation required special procedures due to suspected spinal injuries and internal bleeding that made movement extremely hazardous. Davis rigged specialized evacuation systems that could provide immobilization during descent while maintaining medical monitoring throughout the evacuation process. The first evacuation revealed system performance under actual operational conditions as Rodriguez was successfully lowered to the valley floor where ground medical teams provided immediate treatment and evacuation to medical facilities. System performance validated Davis's technical installation and operational procedures. Subsequent evacuations proceeded systematically with personnel evacuated in order of injury severity and hypothermia progression. Davis managed evacuation operations from the crash site while monitoring weather conditions that continued deteriorating and threatened to make operations impossible. Weather effects increasingly challenged evacuation operations as wind speeds reached sustained 50 miles per hour with gusts exceeding 65 miles per hour that made rope handling extremely difficult and created dangerous conditions for personnel suspended during evacuation operations. Precipitation created icing conditions that affected equipment reliability. Personnel condition deteriorated as hypothermia progressed among remaining casualties who continued exposure to environmental conditions while waiting evacuation. Several soldiers required emergency warming procedures using Davis's emergency supplies while maintaining evacuation sequence priorities. Equipment performance showed effects of environmental conditions and extended operations as rope systems experienced increased wear, hardware showed signs of ice accumulation, and mechanical systems required constant maintenance to ensure continued operational capability during critical evacuation phases. Time pressure increased as daylight decreased and weather conditions approached levels that would make continued operations impossible. Davis accelerated evacuation procedures while maintaining safety standards necessary for preventing additional casualties during rescue operations. By 1800 hours, Davis had successfully evacuated 25 personnel with 5 soldiers remaining at the crash site including himself. Weather conditions were reaching critical levels that threatened to make continued evacuation operations impossible due to wind speeds and visibility that exceeded safe parameters for technical rope operations. The final evacuation phase required maximum technical expertise and risk acceptance as weather conditions exceeded safe operational parameters while 5 soldiers required evacuation before environmental conditions made rescue operations impossible and threatened survival for remaining personnel. Davis prioritized evacuation of the 4 remaining soldiers while planning his own descent using rope systems that had been stressed by extended operations under challenging conditions. Equipment condition assessment revealed were patterns that approached but didn't exceed safety limits for continued operations. Emergency procedures required implementation as weather conditions forced acceleration of evacuation timelines while maintaining safety standards that would prevent rescue system failures during critical phases when personnel were most vulnerable to equipment malfunction or environmental conditions. The fourth-to-last evacuation succeeded despite challenging weather conditions that required exceptional technical skill and equipment management. The soldier reached the valley floor safely, leaving 3 personnel remaining at the crash site as weather conditions continued deteriorating beyond normal operational limits. Communication with base operations indicated that ground evacuation had successfully transported all evacuated personnel to medical facilities where treatment was proceeding according to injury severity. The rescue mission had achieved success in saving lives that would have been lost without technical rescue intervention. Davis completed evacuation of the final 2 soldiers using the last operational capacity of rope systems that had been stressed to maximum limits during extended operations. Both soldiers reached safety despite weather conditions that exceeded normal rescue operational parameters. Solo descent required Davis to use damaged equipment and deteriorated rope systems while descending 300 meters of vertical terrain in weather conditions that made technical climbing extremely hazardous. However, alternative options didn't exist, as remaining at the crash site would result in certain death from environmental exposure. The final descent succeeded through exceptional technical skill, equipment improvisation, and determination that exceeded normal human performance capabilities. Davis reached the valley floor at 2,000 hours after 8 hours of continuous technical rescue operations that had saved 30 lives through individual expertise and courage. The successful rescue. All 31 personnel from the helicopter crash were successfully evacuated and received medical treatment with survival rates that exceeded medical predictions for personnel exposed to severe hypothermia and trauma conditions. Davis's technical rescue had prevented multiple fatalities through individual expertise that exceeded conventional rescue capabilities. Medical assessment revealed that Captain Rodriguez survived critical injuries and made full recovery due to rapid evacuation that enabled immediate surgical intervention. Multiple soldiers required treatment for hypothermia and injuries but recovered completely due to successful rescue operations within critical time constraints. Weather analysis confirmed that environmental conditions became impossible for rescue operations within 2 hours of mission completion, validating Davis's decision to attempt immediate rescue rather than waiting for conventional rescue procedures that would have resulted in multiple fatalities from environmental exposure. Technical assessment of rescue operations indicated that equipment had been stressed to maximum limits while remaining within safety parameters that enabled successful mission completion. Davis's technical expertise and improvisation had enabled rescue capability using equipment that exceeded normal operational specifications. Recognition and rescue legacy. Davis received the Distinguished Flying Cross recognizing his extraordinary rescue achievement and technical expertise that had saved 30 lives through individual courage and capability that exceeded normal rescue operations. The citation emphasized his technical innovation and determination under impossible conditions. More importantly for Davis personally, every rescued soldier understood that their survival had resulted from one rescue specialist's refusal to accept that technical limitations meant abandoning stranded personnel when individual expertise could provide rescue capability within critical time constraints. Davis's rescue techniques became standard training material for military technical rescue programs, demonstrating individual capability and technical innovation that could overcome circumstances that appeared impossible according to conventional rescue assessment and equipment limitations. The rescue operation became legendary among military rescue personnel as an example of individual technical expertise and determination overcoming environmental challenges that exceeded normal rescue capability through innovative techniques and personal courage that saved multiple lives. Davis continued serving in rescue operations while training other specialists in technical rescue procedures and equipment improvisation that could save lives when standard approaches proved inadequate for mission completion under extreme circumstances requiring extraordinary individual effort and technical expertise. Davis understood that his rescue mission had demonstrated the practical meaning of military rescue operations, saving lives through individual technical expertise and determination when soldiers depended on rescue capability that exceeded conventional procedures and required innovation under extreme conditions. Last Signal Stories, Channel Outro. Narrator. And that's Rescue Specialist Davis's rope climber story, the soldier who climbed 300 meters of vertical hell to save 30 lives. Here at Last Signal Stories, we honor every rescue specialist who risks everything to bring others home. If this story of technical courage, determination, and refusing to abandon brothers moved you, hit subscribe for more military stories. Drop a comment below, would you have attempted that impossible climb like Davis? Until next time, stay tuned for the signal.